I think we're live. If someone could confirm that we're live in the public chat, that would be great. Anybody? We're definitely broadcasting, and we're definitely recording. A confirmation would make me feel a lot better before I move forward. Can anyone out there hear me? There we go. Thank you, Linda. Okay, wonderful. Thank you so much. Hi, everyone. I'm Matt Kaufman, and today we're going to have a guest speaker talking about digital twin infrastructure, GCP Architecture Deep Dive. Before we get there, I'll tell you a little bit about myself, about GG Cloud, San Fernando Valley, and the GGG program as a whole. And then at the end, we will have time for questions as well. I'm also going through these slides up front because I know some people can't make it right on time. And so those folks that come a little late will miss out on me speaking, but will make it in time for our guest speaker. So like I said, my name is Matt Kaufman. If you have any questions, there's my handle for almost every service that I'm on. My day job is a Salesforce consultant. I run a small business. My hobby is doing this as a community organizer for the GDG program, Google Developer Group program. And I've been doing it for about 13 years now, based here in Los Angeles. And it really has kind of opened up a lot of doors. I've learned a lot of stuff, met a lot of amazing people, and that's why I like to do it. Here you can see even a picture. This is actually an outdated picture, but we get to go to events and meet fellow like-minded people who are interested in technology. I like to say I'm passionate about technology, and I really love tinkering and playing with new things and trying to figure out what can be done. One of the reasons that I particularly like the Google ecosystem is because the barrier to entry tends to be pretty low. I don't work for Google. The GDG Cloud San Fernando Valley is not a division of Google. We do sometimes get sponsorship from them, but we can talk about anything we want. But I do like that the barrier to entry is low. And what I mean by that is that there's typically a generous free tier for almost all of their APIs and products and things like that. And so you can get started without having to spend a lot of money. I'm actually on a Chromebook, which tends to be a lower cost computer. And I'm able to do all of my work on that too. And so that's one of the things that I really enjoy about it. This is a virtual event. We do have a chat system here, a public chat. So please honor the code of conduct virtually and be respectful of everyone else. If someone says or does something that is inappropriate, hopefully I will see it in the public chat, but I am multitasking. So if I don't see it, just let me know. And we will try to take the appropriate action. This code of conduct also applies to our in-person events. So if you are able to attend any of our in-person events, either for our chapter or for any other chapters around the world, hopefully you'd be able to honor the same code of conduct. We won't have too many housekeeping things here today. So again, I'm going to just kind of quickly go through some of the benefits of the GD program, and then we'll get to our main speaker. But like I mentioned already, I'm going to meet a lot of amazing people. I'm always amazed that I can go to an event and meet someone who grew up in a different country, spoke a different language for most of their life, looks different, dresses different, uses a different kind of computer, and yet we can have so much in common. And so that's one of the really nice things about these communities, that it brings people together across all these barriers. We do get a lot of free training, which is nice. Like I said, I learned a lot of new skills. I played with a lot of new technologies that were really outside of my comfort zone, but now I feel like are kind of second nature to me. So that's nice. And then there's some, a little more tangible benefits. We get access to cloud credits to try out different technologies. Same thing also for the Skills Boost program to be able to do courses and things like that, which is great. Sometimes we get invited to events. So for those of you that may not know, Google Cloud Next is coming up in a couple weeks. It's in Las Vegas, and that's the annual conference related to Google Cloud Platform. And so that's an exciting trade show type of event, but there's a lot of neat sessions. The agenda actually came out today with the schedule, and so you could see that. And then next month, or sorry, in 2 months, in May, is Google I/O, which is Google's annual developer conference, which is a much smaller conference, but is very intimate. You're going to meet a lot of people, all again, very similar people with similar interests and stuff like that. And so I do enjoy that a lot. And then, of course, another benefit is just some publicity and recognition for doing this type of stuff. 1 second, there we go. The requirements. So I'm just like you if you're watching this. I'm not special. I'm just a normal person that about 13 years ago decided to start volunteering as a community organizer. And anyone can do it. And you can do it as much or as little as you want. Your level of involvement is totally up to you. Your skill set can be different too. You don't have to be the person that's on camera and doing the talking. You could be a person that helps with social media or builds websites or anything really. So that's an easy kind of way to just help out. We always need help because it is volunteer run. There's some requirements from the GGG program itself. There's an NDA, there's a code of conduct that we just looked at. We do ask that you at least volunteer somewhat consistently, so you don't just show up right before a big conference. And we have to organize usually a certain number of meetings a year, but with more people volunteering, that becomes easier every time. There are a couple bigger campaigns that we also try to do, like DevFest and IWD and things like that. For those of you that don't know, DevFest is an annual developer festival that we typically do in the last part of the year, so like August to December-ish. Here in LA, we did ours in December. It was a big event that we had at the Pasadena Convention Center, but they do happen throughout the season. And then IWD is International Women's Day, and we will be having an event for that in LA coming up very soon, actually, in like a week. So I think I have stalled long enough that if anyone was running late from traffic or had to restart their computer after work or anything like that, hopefully you're here now and welcome. And if not, we are recording this and we'll hopefully be able to make it available. So I'm going to turn this over to our presenter, Arun Srivastava, and he will be talking to us about his talk on digital twin infrastructure, GCP Architecture Deep Dive. And Arun, feel free to take it away.
Yeah, okay. So let me share my screen.
Yeah,
sorry,
please.
one second. It should be this. Oh, wait, sorry, one second.
That's okay.
Okay, that should work. All right, hey, so as you've heard, my name is So as you've heard, my name is Arun Srivastava, and today I'll be talking about digital twins on Google Cloud. Now, before we can begin to roll the nitty-gritty, we first need to understand what a digital twin is. Now, the idea behind a digital twin is rather simple. All it says is that you have a copy of you over the internet, a healthcare copy of you. Now, the reason that this is useful should be pretty obvious. It allows us to do treatment on a digital version of you rather than trying it on the real life version of you. When this becomes extremely useful is in cases of cancer. So during those times when the general treatment plan right now is, okay, we have a general treatment plan for most patients that, let's say, gastrological and cancer, that this type of medication or this level works for most people. We'll give that a try and then we'll refine it as we see how it impacts you. With a digital twin, we can do that refinement on the digital twin instead, which is far quicker and which then can help in being far more effective as a treatment plan. Now, let me tell you, I did not create that. I'll preface this by saying I did not just create, like me as a patient, I put in my information, I say I have cancer, and then you get a treatment plan out right out of that. I did not create that. That would have been too difficult. So I am what I've created instead is the base fundamental of a digital twin. Imagine you're the technical guy, right? The healthcare company comes to you and like, okay, we want to create a digital twin. How would you do it? What are the challenges that you'll face in creating the base part of it? This is what I like to call more like the zero step of creating a digital twin. So where's the first issue you'll deal with? Well, the reality of healthcare, which is messy data. See, data is extremely fragmented across healthcare, especially when you're dealing in healthcare with like things like sorry, one sec. Things like, let's say you have a heartbeat, right? So there's multiple things you'll be taking your heartbeat, your pulse oximeter, your, I don't know, blood pressure machine. All of these other things will be taking your heart medication, let's say, like the heart rate, and none of them are talking to each other. None of them, since it's across different vendors, none of them share any similar scheme or format. So that creates immense issues in getting all that data to be centralized, which is what the first step would be to creating any digital twin. You first need the data, right? Another issue is latency, right? We can't just do it in like batch jobs, which is ideally how it's done right now, I believe. In most healthcare systems, is it's done through a batch job. But the issue with batch jobs is that it only happens 10, maybe 15 minutes, and that can create major issues because in healthcare you don't have sometimes you might not have that much time. Another major issue is in healthcare data hardware is not perfect, right? Up until now, we'd assume that no hardware is going to send you completely perfect data all the time. Sometimes it's going to be wrong. Sometimes it might only send partial data. Sometimes it might even fail to send data through. These are the type of issues you'll deal with healthcare, and these are unique to healthcare, I feel like. Another major issue in healthcare, reliability, right? This needs to be extremely reliable. We're dealing with patient health and patient safety. It cannot ever fail, right? Um, One major thing is historical data. We need to be able to see the data that was previously, the previous view of data for a healthcare patient. It can't be just, oh, okay, his pulse oximeter was reading 89 heartbeats per second or something 2 minutes ago. We don't have 10 minutes ago because the batch order didn't send or something like that. We can't drop data. Data has to be completely accurate. There are major silent errors that can be created, such as out of order data or data event time, the timing of data being wrong. Let's say an event happened at 10:35, we're getting the error at like 10:42. 6-7 minutes, huge issues, right? For healthcare, it can be. Other things is multiple types of data coming in, which one to take. These type of errors for traditional databases can create humongous issues that can be because they're not as versatile or open-ended to deal with, or they can be, but then the cost of the complexity goes up. Which for health, these are healthcare companies, not tech companies, which means we want to keep the cost as minimal as we can since they're not in the tech business, right? And when you later on you create the AI console, you create the final treatment plan. It needs to be extremely correct. It needs to be mathematically correct, and most of all, it needs to have the ability to be tested consistently, right? Again, when you have traditional databases and traditional methods, you're going to have issues of, okay, now we've updated our logic. Well, now there's major issues. All of a sudden, the format's not working, or data's not working, or God forbid, you have to change the data to make the logic work, which we cannot do in healthcare. Data cannot change. We need the base data. So essentially, the foundation of this architecture is two things. One, that the data cannot change. As such, this architecture is append only. You cannot remove data. You cannot manipulate data. And the second thing is replayability. If the logic evolves, we need to be able to use the old data, which, as I'll talk about, we've done by dividing the data into two different sets, which allows us to keep one data that is consistent throughout. Like I said, multi-source conflict is a major issue, right? Because let's say we have the ECG, SpO2 here, like, right? You have the ECG, you have the pulse oximeter, which is SpO2, and then a ManoBS, I believe, is heart rate monitor. All three of them giving you the heart rate or the BPM. All three are different. Now, how do we choose which data, which point of data do we take, right? Which value do we take? These things will be decided by freshness and truthfulness, as we'll talk later. One major thing about this architecture, we did not choose at ingestion points, which means when the data is being streamed in, we're not like deciding, okay, remove the pulse oximeter and the variable, just keep the heart rate monitor data. No, we'll take in all three. We'll decide later on which data to keep, but we will have access to all three to make sure no data is lost at any point. So again, the architecture overview is pretty simple. This is a very high level. We have the raw ingestion. This I call the bronze layer. This is the messy input. This type of data, it can be anything you want, right? The schema is not, it doesn't matter. This is the bronze, the way the database is set up. It allows for most, if not all formats, at least it's supposed to, right? In my basic demo. We won't be testing it very thoroughly, but essentially the raw base will allow for all types of data sets to be allowed in, so we have a record of it for auditing, for checking on later. Then you have the event stream. This is making sure that the data is being streamed to all the services that would be required to do, right? Be it your Looker, your trusted, your other database servers, this is basically our pub sub of streaming data. Stateless logic is extremely important because one thing you don't want it to happen is data to become corrupted later down the line. See, let's say let's say we had stateful data, right? If we had stateful data, the way the data would work is, okay, let's say PubSub takes in some data, or let PubSub is stateless, but let's say, it was stateful for a minute. It takes in data and it has some memory of the patient. Let's say patient X, 2 seconds ago, its heart rate was 120. We got a new heart rate, it's 92. Now what it should do is send a 92. For some reason, it sends 120 again. That can create major issues down the stream because now all of a sudden, all the data down the stream has become corrupted, which is not what we want, that kind of makes it pointless and extremely prone to error. So just to be safe, you make it stateless. It also means that it's extremely scalable and far simpler to use, which means cost is less, which is something we extremely want. Now, the trusted state is the silver. Now, this is basically where you curate the data. This is the data that you'll be showing to doctors, essentially. This data would be extremely curated. There will only be, any data that has been repeated, which would stick in bronze. Like, let's say a machine sent the pulse oximeter, sent it the heartbeat twice. While in bronze, that's fine. In the trusted state, though, in the silver, we would only show that up once. We wouldn't show that up multiple times, right? This would be curated. Each data set in this silver would also be showing specific things to specific people, right? To like the radiologist, it would only show specific types of data, be it MRI related, whatever. And then which it takes from the pool of the bronze data, and then to the cardiologist is showing only the heartbeat, the heart monitor data sets. This is to make sure that we don't put so much noise on the doctors, that because usually their issue isn't having too much data, it's having too much data. So the goal here is to remove all the noise and only give what is extremely required. And this is an in-depth view of the architect. So there's our data sources, right? We have the ICU monitor, wearable device, lab system, EHR system. These are heterogeneous clinical data sources. And as such, they can be anything, really. They all go through the cloud PubSub. Now, I use PubSub over Kafka simply to reduce cost and to streamline it. You could use Kafka, though, as Kafka is extremely throughput and has high throughput. But I find that for most hospitals, that probably would not be required, that extreme level. But yeah, anyways. So then we have the push subscription, which then sends it to Cloud Run. Now, this is basically the brain of it right now. It has your validation, your deduplication, your idempotency. God, that's a hard word to say. And then your event time and lightweight risk enrichment. This is basically the brain of it all, right? This is going to be subscriber.py, I'll explain later. And now it can be sent to 2 different data sets. It's going to be sent to the bronze, which is, as I said, append only, and audit grade. And then there's the BigQuery silver, right? This is going to be normalized. The data that doctors and radiologists and whatever they would use in day to day. Now this would be sent to here to Looker is where I sent it, but that's just a temporary dashboard. If you were to create an actual dashboard, it would be obviously somewhere else. Looker data set isn't what you're using in hospitals. It's merely for examples. Now, one very important thing, as I've said before, is event time. Now, event time is extremely important, right? Because that is the clinical truth. If your measurement is taken at 8 o'clock, but the time you're seeing it as a doctor is 8:35, we need to know that, right? We need to know, as you'll see in the data set, that the data came at 8 o'clock, not 8:35, right? And because that allows us to create scores of freshness, as we'll talk later, freshness, cross management, and then other data sets. And that says it's an async ingest temporal resolution. That's the protocol that's being used. It's nothing just basic about making sure that the event time and the ingest time are never synced together. Now, again, bronze is immutable. It's append only, clinical trust, and access. That's all basic. Here, what I want to talk about is the things that we created. So first thing was a deduct key, or making sure that there's a deduction key, as I like to call it, or I think it's deduction. I'm not sure what it's called, but I call it dedup. So that's basically making sure that each data set has its own unique key. Now that's important because let's say a patient, like I was talking the pulse oximeter, let's say you get two of the same thing, then we need to be able to, the system needs to be able to differentiate and say, oh, these two are the same things. Okay, it needs to know that, and that is done by a unique key that would be given in the ingestion point of view, right? So that would also be shown in the bronze. And again, it's immutable even to developers, legal compliance, clinical trust, all that other fun stuff. This is where you audit. This would be the constant auditing. This would honestly never be touched by basically anybody other than developers, and also sparingly. That would be the idea. And again, extreme security on this. Only those who need it would get it. Now, again, this is the decision integrity. Right, this is the difference between bronze versus silver. You have the bronze, which is the forensic truth, and you have silver, which is clinical integrity. Right. Now here in silver, we would even define it even more by things like freshness, by things like, again, to get rid of all the noise that we see here on the day to day, right? To get all of rid of filters the noise and resolves conflict. All of that would be removed through filtering, by be it freshness, be it making sure to only take one data set of heart rate, be it um, not having repeated data in there. All of these types of things would be put in there, right? To make sure that silver is only the things that are required. So again, silver is the resolution. It is not storage, right? This is only going to be the event time. This is there's things like confidence scoring and clinical logic rather than just orders. So like in let's say you have a patient that comes in, he's like, okay, the variable sensor data, its heart rate is 82, and then you also have the ICU monitor send in their data, which is the heart rate was 112, but the ICU monitor was 20 minutes ago. This variable is very recent. Which data do you take, despite the fact that the ICU is technically more important because it in the respect corner, like if you would, it is far more trustworthy of a data set. Which one do you take? These type of things would be decided at the silver level. This is what we would be deciding of, okay, well, sure, that the heart monitor is technically more trustworthy, but it's 20 minutes old, so we have to use the variable. In these type of rule-based logic, as I shown in the code, is decided at that point. Now, yeah. So again, this is where naive systems would fail, right? The one thing is, again, duplications, new device formats. Breaking old logic is a huge one because in medical sciences, there are constantly new devices. I mean, there's a whole industry called medical devices that update devices, which means updated formats. You know, GE never talks to I don't know what's another Sony. They or Samsung, they create both of them create devices, and yet they are notoriously known to never talk to each other and have complete opposite data schemas, which on a Trace database means logic broken, right? Which in cloud in this architecture mean is because we've differentiated between silver and bronze, it allows us to create pathways to for both logics to run at the same time. You have the independency, which is the um, in most sometimes architects, they just they won't allow for packets to be rerun, right? Packets will be like, oh, we tried it once, it failed, well, packet's gone. PubSub, the way I have it, you have the ability, PubSub inherently, it allows you to create the system. I have it done on the base, which is based on the base configuration, which is up to 5 times. I'll try, and then even then, even if it fails, then it will be sent to a third database, which is just saying, oh, this is bad data, or review the data. Time skew, again, this is your late data arriving after state is closed. Um, Extremely important that we know that this data has been able to be late, that we still have the data as is required, because you never know when it's going to be good or bad. Duplications, network retries, counting doses, right? We pretty self-explanatory. Another thing was making sure that, sorry, like data arriving after stage. Yeah. So another thing is making sure that once data, Sorry, forgot. Never mind then. All right. So now we could switch to a demo. We'll switch to a live environment right now. So here we go. If we would, sorry. All right. We could open up the terminal. So let me open up the code I have put in here. Sorry. So one sec. Okay. So we have first. Let's. I'm already logged into my digital twin code. So or my Google Cloud. So I'll just transfer to digital twin. I'll go to source. Oh, sorry. When and now you're inside the van. And now here's the entire architecture again with all the G-Cloud config list. This just shows that we're in here. So now, the first demo that I'll be doing is to show the dedup theory, to show the fact that this architecture. Oh, sorry. It's wrong. Sorry, one sec. Well, you know what? Let me just do it. Okay. Let's. Okay. So CD ingestion. So now these are the publisher. These are basically the code that we would be running. These are basically all the files that we would be running with. That would so basically this is so instead of creating data from actual healthcare devices or whatever, I have created my own personal data for the time being, as it's kind of hard to get fake data or realistic data that would have violated HIPAA. So for the demo, we will just be using practice data, dummy data. So here we have Python publisher py. Okay. Yeah. All right. So now we could go to our Cloud Console. Okay. So here we have it. So this is in bronze. Here's our normal data. So in bronze, as you can see, yes. So this is our bronze. As you can see, this is just giving you data, your heart rate, your SpO2, fresh stable, and that's it. This is just basically your data in a non-readable format here, and then in your or non-normalized. This is just, and this type of data, I could have shown different types of schemas, but this can basically take any schema. If you look at the actual table of it, it would be extremely open to taking just about any other schema. I could show the table schema later. And then, again, so now this would be the data, right, that we would be seeing. Here we are. So here's the overall confidence of the data, how much we think about data, because again, in here, things about that we could see were freshness, how fresh was the data, how long ago was the data, what are the tools being used. So at the end of every day, we get an overall confidence score. And one very important thing about this is all of this would also be also allow for doctors to change as is required, right? They, if you could, I could just show you the actual code. We should be able to put a finder here. So if you go to a digital twin, in here, inference. So here we can easily change the code for any of the, right. So here is the real-time code that could be easily changed. Obviously, this wouldn't be shown to doctors, but this is all to showcase that we can easily, if you were to do this in a console method, it would be a couple of buttons to change as the doctor requires to make sure that they have complete transparency. Because one of the major reasons a healthcare, a project like this or a tool like this might not be used is simply because doctors don't trust the process, the idea, or they just don't trust the base technology behind it, since they cannot actually change it or it looks like a black box. That can't happen for doctors, right? They need to be able to change the data as it's required, or be able to see how the process is working for all of it. Now, again, another thing that we'll see that we can test out is being duplicates. Publisher duplicate py. So, okay, now see, here we have, so if we were to go right now to this first one, I've already run the theories, so I have those. So here, as you can see, there was no data display because it took the duplicates, because these are essentially the exact same things. And then in the silver set, it said, okay, no, we're not going to show any of it in any of it if you have a count more than one. So it removed the duplication process of it all. Okay, now, and then one other thing we can test is, this is the, again, the freshness score I want to showcase was this publisher slash stale.py. Now this is important as the freshness scores. This would be this third one, I believe. Yes. So here we go. Okay. Yes. So here you can see it deciding that, okay, patient fresh one, and it tells the second 6, 76, 26. And again, this is just done on rule based. 26 is aging, 76 is stale, and fresh is extremely fresh. Like 6 seconds is fresh. And that was this. And here you can even see the reason on the side. All of these things are extremely important to showcase because for the doc, they need to know exactly why and when why the system did what it did, and they need to be able to change that extremely easily. Right now, obviously, I didn't create a console for it, but if you were to, it would be a simple click of buttons, making sure it's all very easy to see. Now, the major thing is from here is actually this stuff. So this is going to be your Python. This is extremely important. Is your publisher publisher that's the one, right? Slash conflict dot py. This is extremely important as this is what you do when you have multiple of the same thing. This is essentially the heart of the project, if you will. So here, like, let's see, we have patient number one, right? He got his heart rate from the bedside monitor, from the variable, again, from the bedside monitor. You know, these things are being set multiple times. The pulse oximeter, the variable, and now all of this has been sent at an extremely quick rate, right? It's probably been spent in a couple of seconds to a minute, or right, to a couple of seconds to a minute at most, probably. Now here is extremely important is the HR confidence. This is going to say, okay, the bedside monitor, extremely confident. Wearable, not so much. Pulse oximeter, not so much. Wearable, again, not so much. And now you have the freshness, which is how fresh, aging, fresh. How fresh is data? How quickly they come? Is it 20 minutes late? Was it 2 seconds ago? This is the data. Okay. And this is another one, the SpO2, blood pressure, all of these things, right? And again, as I said, we have made a difference, made sure to write the event time out because doctors need to know exactly when this data came in. They, not when it came inside the system, but when the doctor saw it. Okay, so this is this again tells them, okay, this came in at 6:48, 6:52, whatever. Okay, now at the end will be the final merged point of view, which is the merge. This is the result state. It said, okay, now we're going to taking all of this into account, all of this data of different heartbeats, different heart rates, whatever. We took all that into account. Okay, we're taking 78 as the heart rate. The confidence, 95% that the system is confident. Again, this is extremely important for a doctor to know that how confident are we with this, whatever they said they can check into later, and for us to know, okay, how important is this? And it also tells, okay, how fresh is the data that we're using, all of these types of things. Again, each system here, some of them SPO2, like again, if you were to look into the actual code of the finder of subscriber.py, you will see that there's multiple logic here of what was taken. Some might be decided on like here, if system BYP is over the alert, then it returns the alert system, right? So like here, if you have a try event replaced with the times, again, the freshness of it all, there is basic mathematics all done here. I mean, we can see here, if you will, I'm sure, I feel like there was, maybe not. Okay, so if you were there, in here, right now, I've done very basic logic to just showcase this, like here, right, just to showcase all of it. This is the Cloud Run code. So when you change this code, it would be implemented straight into GCP. This would be the brain of it, you could do this inside GCP, but I think most people would differentiate between the application code of it, the application servers, and the database servers, which is why I've done this on my own local device. Technically, you could do this in GCP, but I would not recommend that. You would want to separate your application server and your database server. Again, this is the main heart of it. This is the basic very early features of this stuff. As I said, this would be the very early feature. If you could imagine this on later end, this would have treatment plans. It would be extremely on the point with far more capability of it all. Yeah, that would be that part. And then there's one more, which is you have, okay, this is another important one of what happens when, sorry, one sec. What happens when data, let me just do this, when data is bad. So here we have Python publisher bad message. Now this will take a minute to show, so we will move on forward and then, okay. Sorry, it's on publisher. Okay. Okay, and then publisher put on that message. Oh. Okay. Now this is what happens when here you can see that the raw data is just bad JSON or no data at all. The reason for bad data wouldn't it's not just that bronze layer can just take everything, right? Because it will usually when you will create the bronze layer, there will be in the base layer all the acceptable schemas, and if something is out of that schema, we will consider as bad data because again in healthcare you're going to get loads of data that just doesn't work or is unrequired, or perhaps it's like, oh, the medical device only sent half the heart rate monitor, or it in the middle of being the IV being put in, it was taken out, so the heart rate monitor it was starting to be streamed but never fully sent. So all those types of datas, they shouldn't be clogging up the bronze layer because they have absolutely no use case in that. So for that but we should still be able to see that data if need be, and for that you can see that in the cloud log, if you will, inside pub/sub. For a little while you'll be able to pull that data up just to be in case you need it, but it will be in the vitals DLQ, data that was just not usable or not needed. So if you would go inside the vitals subscription and then you would pull that data, sorry, in the messages you would pull it. Hopefully it shows up. And again, you would see bad device. It was March 12, 24 p.m. It's okay. This is bad data. We don't need this. Okay, 1:30. Yeah, 5:37 p.m. This is sorry. This is the latest. And you got there was no data and it was bad JSON. Now again, this is deadline expanded, which means it's sended for like 3 or 4 times, like 5 times, right? It's sended multiple times and it just failed to receive. It's like, nope. Bronze like we won't take it, we won't take it, we won't take it. So it was sent to messages. Obviously, you can arc down messages later on. You could decide, okay, we've every 30 days to arc the messages because you don't want this message just being, being built up with that bunch of data. These are the major things I've created for my project to make sure that it's actually healthcare resilient. These are the type of things that you would have to think about and actually use, right? Making sure that the data is safe, making sure that the data can change. Oh, like one other thing we did, if you were sorry, is in here, if you would look inside the bronze raw. So when I was doing just the event ingest like this was creating issues because it was taking immense amounts of time to query, so I had to then create an event ingest a flat, which was a lot easier to just send the data through because everything was simplified in a far more easier way and made far more BigQuery friendly. So like these are type of things one would have to think about to create this type of data, right? Silver curated is particularly interesting because right now all I've done is write it for dashboard. But if I want, I can make this write it for dashboard for cardiology, and then create another one write it for dashboard for radiologist, and one after the other. And given the fact that we have streaming data, it makes it extremely easy to do and create. Okay, and then one other thing. Okay, yeah. So we'll continue on. I'll see. I saw a question. I'll answer that later in a second. James. Okay. And then yeah. Sorry. One sec.
We also had two questions in the
I
Q&A
have two
panel.
monitors open, so it just changes it up. Now, the one more important part comes in is the evolution. Now, one thing you'll notice in this architecture, there was absolutely no AI. That was done by design. Here, what I wanted to show case is again the zero step of this. There is no ML, there's no AI. Everything here was done rule based because when you add all that fancy ML, all that fancy AI, you're going to need it to be far more medical certainty. You're going to need HIPAA, make sure that it's HIPAA concrete. You need to make sure that all that data, all of the ML AI formats is easily to see. It can be extremely transparent and can change as is required, right? So for that, that is stuff you add in the future, right? When you create the base testing of it, the first rendition of it, it will almost always be non-AI based, always be um, rule based. Now, the plan for ML scoring that I plan to add, so this was there's two types, right? There's the one that I showed where it's like, oh, the AI sees freshness and decides which one to showcase. There's also one other one where, let's say you get a heart attack, right? And for some reason on that database, on the treatment plan, the heart rate monitor, or there is no heartbeat on the database. Like for that patient, for some reason, there is no heartbeat shown that was ingested into the data. Now, for that case, what the ML, like I want to create later on, is an ML would then create a data. Now, of course, there would be multiple points of view to stop this. In the console, when ML is like, oh, we're going to create a heartbeat, it's like of 50 of 82. First, it would have to be hard start by the doctor. They would have to approve it. When the ML is like, okay, I'm creating a heartbeat. On this treatment plan, I would need to create a synthetic heartbeat on the console shows up. It's like, okay, I'm adding a heartbeat. Do you approve this, or do you have one that you could manually add? Also, the confidence level of that treatment plan will also have to go down, and making these types of things would have to be added into the console to make sure that it isn't just black magic and we're able to see everything that is happening. Again, this would have to be privacy, updated data masking retroactively in the replay layer, pretty obvious, right? And all the other HIPAA violations, make sure it's HIPAA compliant, CME key, and all the other cloud-based technologies that we need to do to make this extremely safe. Another thing is scale independently as the data complexity grows. That is why one of the reasons we made a stateless, as I talked about before, of making this here stateless logic. It allows this to grow far quicker than if it's stateful, and it'll make sure that the complexity is much less. Which is one of the reasons I didn't use things like Kafka or any third party, because the minute you do that, you increase complexity, which then makes scaling more difficult. Now, adapters is making sure that this is one thing that Google Cloud is extremely useful for. It allows for allows for modularity, which means you can attach things as is required, and makes it far easier to attach things without interrupting the base flow. Right? You can test it, and you can just you say, okay, Kafka, we want to upgrade the logic for a radiologist. So you just do it. You go into you upgrade the publisher.py, you upgrade the logic as is required, and for radiologists, and only the radiologist data set changes. None of the other ones change. So that's, and then obviously things like formatting changes. Again, making sure that bronzes can constantly update and it almost always be open. Remember, Google Cloud also allows to make sure that the data is constantly valid. Or that the sorry, I lost my train of thought. One sec. Just constantly valid. Never mind. I seem to have forgotten that my right, that it allows for the schema to be constantly evolved for bronze, because let's say G comes up with a new type of sensory data point of view. First, we would just run it through bronze to see if it's applicable in that, or else we would change the bronze to allow it. Again, never ever allowing bronze to be allowed to manipulate or delete data. It will always only have append only um, capabilities. And then yeah, that would be the end of it. And then yeah, So again, truth is durable. We need to make sure that nothing is constantly changing, and we have to design for time. So those are the basic fundamentals here that I want to showcase in this topic. And the fact that using GCP is extremely valid here because you cannot increase complexity too much. This is not a tech company or like healthcare industry. This is not a tech industry. Spending millions into Kafka or the other various tools that we can use that are being used right now would not be a good idea because it just increases complexity, and that is not healthcare is not where they want to be spending their time and energy into tech. We also do not want to increase cost, complexity. One third thing. I think those are also being compliant with HIPAA becomes far easier when you're using one base as your architecture, or like using just one simple architecture rather than trying to do it from multiple different types of architectures. So yeah, that's my project. This might turn into a series. This is just a zeroed step. I should have just named it zeroed step. This is very fundamental into just imagine you have to create the architecture right now. What is the base minimum that you can get away with without adding anything fancy? That was the goal of this architect, to make it as to just create the base by making it extremely simple to reduce complexity and make sure it is very uh, healthcare forward, because healthcare has very unique challenges that others don't. So yeah.
Okay, awesome. Thank you so much.
And
We
then
do have some
James, you had a question to edit, run database server code on the cloud and app code. No. So I didn't. Database server code is also done right now on my local Python code right now. Or I did run the database server code through Cloud Run, but as for editing, the way the IAM permit services are done, you cannot edit the code through Cloud Run. You can only do that through locally, because again, that would create issues of just Google services being messing with Cloud Run, or somebody from Google or from their side messing with app services code, which no HIPAA compliant or healthcare services would allow. The code is run through Cloud Run, that is run through Google services. You can change that to a third app server, but I didn't feel that there was any point in just changing it to a local third service, unless I didn't feel any need for that, at least. Any more questions? Anybody?
So yeah, we actually have some questions in the Q&A tab. Arun, are you able to hear me?
I can't hear you.
Okay,
Sorry.
let me turn you off of presenter mode real quick. Are you able to hear me now? Let's see if I can try this one more time. Arun, are you able to hear me now? You're on.
Sorry, I can't hear anything that you're saying. Sorry.
You can't hear me now?
Nothing. Sorry.
Okay, that's okay. So what I'm going to do, if you
any other questions, please ask. I would love to.
Yeah. So
I guess other things I could talk about or other major issues I was dealing with. Sorry.
Yeah. Okay. So I'll try.
There was one other thing I wanted to talk about. Sorry, I forgot. One sec. Preserve. Silent errors are extremely annoying because when I tried doing this through a third. That it might just be me. Let me give me one sec. Let me try to.
So while he's working that out,
let me see if I can't do anything about that.
Okay. Because I did see there are some questions.
One sec. Default. You know what?
Let's see if we can do this.
MacBook Air speakers.
All right. So
now I can hear you. Yeah.
Okay.
Sorry.
So there are some questions in the Q&A panel. If you want, I can read them to you, or if you want,
I didn't see that. Okay. Yeah.
Yeah.
Let me find that.
Sure. I can read them to you if you want. It's
I just, for some reason I can't see them.
Okay. Yeah, that's fine.
Yeah.
So the first question is, when gathering data, do you need to record the machine type or serial number or something to be able to look for maybe faulty machines and things like that?
What I have done, I'm assuming that because I'm assuming that healthcare does that already, because when the data is coming in, through multiple, because remember, these are multiple types of data that are coming in through through to me, or like through the GCP. So obviously there's a layer below me that compiles all the data initially, because I'm not going to work on, it's basically like Uber. I'm not going to be in I'm not going to be like Uber, people in Uber, right? There's two types of it. There's the ones who will locate all the geographical data, and there's the ones who will ingest and use that data. So the actual gathering of the data would be done with somebody in I think, lower services than mine. Mine is ingestion and actual compilation of the data. So out of data or invalid machinery, I think that would be handled with below me. But that could easily also be added for redundancy check, which wouldn't be a bad idea. Thank
Yeah,
you.
that
I
makes
could use
sense.
that.
Okay. Next question, and you may have talked about this a little bit, but how do you manage privacy and data retention?
So data retention is done obviously through bronze. That is the main data retention point of view. So um, and that the data is going to be managed through bronze, as I've talked about multiple times. That is going to be your data where everything just comes through. There's no checking. Like there's even ingestion. Basically, the data gets streamed in, and it's through the bronze is basically a bucket that just takes all the data.
Mhm.
There's not going to be any changes. There's not going to be any drops. There's not going to be any pickups. So that's how we can audit it and make sure nothing's lost. Even data that failed to send is sent to as I showed you in my last demo, the sent to a vitals DL2. So even if data that wasn't sent for any reason, bronze rejected it, it will still be there because we need to make sure no data is lost. As for security, again, your IAM services, making sure least privileges, CME, and then HIPAA and all that stuff. Obviously, I didn't add that because this was the base architecture, but those are things that would be taken care of.
Okay, and then the last question that's there right now, at least, do you provide a different silver data tranche for each profile that will read it? For example, a cardiologist versus a radiologist, that
Yes.
type of thing.
Yes. So I didn't do that because I didn't feel I was required for this demo. But yes, I could very easily add for radiologists, for cardiologists, because that's obviously how that's going to work. No one script or silver-based data is going to work for all, right? For both the cardiologist or the radiologist. But that just becomes kind of useless because at the end of the day, that creates noise. And one of the most important things in this archetype is to reduce all the noise, or else this won't be used. And to validate that further, to make sure that everything here is being used, there would be two things that would be done. One, a feedback loop by the clinicians themselves, and then a behavior analysis of actually seeing when is the doctor's overriding or not even looking at the data. Because then we'd be like, oh, cardiologists almost never look at, I don't know, the bone structure of some heart
Mhm.
muscle, something. I don't know, right? I don't know
Yeah.
the particulars. So then we're just going to remove that from the silver database. So that way we can remove noise and only give the important parts.
Okay, awesome. Thank you. I think that was the last question. I'm going to go ahead and pull up my slides just to kind of close things out. So thanks again, Arun, for that. That was great. I really like it when a topic is not just how can we make a lot of money with code and things like that and build stuff that doesn't really make an impact on the world, but when you're talking about health or other things like the environment, it's really nice to see that we can use our talents and skills to make the world a better place. So I really like this topic. So thank you so much. Thank you to all of our attendees as well. As I mentioned at the beginning, this is a volunteer organization, and so we're always looking for more help. If there's a talk that you would like to give, let me know. If you have a topic you want to learn about, let me know also, because I can always try to find someone to speak on that topic. And if you have a venue or a sponsor who might be able to help us out, please, please, please let me know as well. And finally, if you yourself have some type of skill or talent that you think would make our community a better place and you would like to help us, definitely let me know. And if you're not in the LA area and you don't want to help our chapter, there are GDG chapters around the world, so please reach out to them. And then finally, just one last thing. If you are in the LA area, here's the next event that we're having from the multiple GDG chapters in the LA area. It's an International Women's Day event that I mentioned earlier. It'll be an in-person event, April 11th at 11 a.m. And you can sign up. You can buy a ticket. It is an event with a meal, so there's a cost. but you can buy a ticket by scanning that QR code or going to the GDG website, and you'll find it there as well. So thank you, everyone. I hope to see you again next time, and have a great evening. Bye-bye.